Hey guys, so this is problem 189, rotate array. So we are going to discuss a few of the details about how to solve this problem, a very important one because somehow you can use this problem in a lot of other programs, a lot of other problems as well. So quite important. So it is a medium level problem, right, as we can see, and we're going to discuss a lot of different approaches to solve this problem. So what does the problem statement says? So given an integer array nums, right? So we are given up with this nums array. For example, right here we have this array. So let us write it down. 1, 2, 3, 4, 5, 6, and 7, right? And k is equals to 3, right? So given an integer array nums, rotate the array to the right, right? So we have to rotate it to the right, by k steps, where k is a non-negative number, of course. So when we have rotated it from the right side, so first of all, there are 3 rotations that has to be made. This is what k indicates, right? So first of all, 7 will come at the first position in the first rotation. So rotation number 1 would be 7, 1, 2, 3, 4, 5, 6, right? So this was rotation number 1, but we have to do 3 rotations. So now rotation number 2 would be rotation number 2 would be 6. 6 will come at the front because this rotation has been made, right? Then 7, then 1, 2, 3, 4, and 5. And afterwards, the last rotation, that is k is equals to 3. So here the rotation would be 5 will come at the front. So 5, 6, 7, then 1, 2, 3, 4. So this is our final array, the output. That is 5, 6, 7, 1, 2, 3, and 4. Now, if we'll see one thing, it will come to our mind. One thing will be very clear, will be made very clear. That is, we are not returning anything, right? It means that if we are not returning anything, it simply means that it has to be an in place rotation, right? In place rotation simply means that instead of having a new array and copying and pasting everything into that, we are not allowed to do so. What we have to do is instead that we have to rotate all the elements within nums array that we are provided with, right? So we cannot return any array. We have to do in place rotation. That means the nums array that we are given with should be ordered in such a way that it should contain these elements in this particular order, right? So afterwards, we are done with the question. Now, before going for the solutions, let's see one more thing here. That would be the constants. So here we can see that nums dot length can be up to 10 raised to the power 5. That is, nums array can store these many elements. All right. So it is in integer range only. Afterwards, nums I can be from of integer range, of course, means because it is minus 2 raised to the power 31 to 2 raised to the power 31 minus 1, which is an integer range. Hence we have all the elements within integer array of type integer, of course. And then the important part would be this k. So it is written that k can be from 0 to 10 raised to the power 5, and it has no relation with nums. So we have to take care of this, that even so what it means is that if suppose I have this array nums of size 60, k can be 90 also, right? K can be 90 also because there is no relation of k with nums array, right? So we have to keep this in mind that k can be anything. So for example, if we have this array 1, 2, 3, 4 and it is written that k is equals to 6, it simply means that you have to go k times. So if you'll make rotation 6 times, the array would become something like this. On first rotation, it will be 4, 1, 2, 3. On second rotation, it will become 3 4 1 2. On third rotation, it will become 2 3 4 1. Wherein in the fourth rotation, it is again the same array, that is 1 2 3 4. Now again, if we'll start with the fifth rotation, it will be 4 1 2 3, and the sixth one, that is our final one, would be 3 4 1 and 2. Now if you'll see at the end, the rotation that we are getting here, the final answer is basically 2 times rotation, right? So it is similar to what we were getting here, that is when we have rotated our array 2 times. It is here. So when we have rotated our array 2 times, it's the same answer. It simply means that if we'll do something like this, that k is equals to 6 mod the length of array, that is 4, you'll get 2, isn't it? So we can just change the value from 6 to 2. So this is the very first thing that we're going to do, that will mod divide our k with our num, so that extra rotations that maybe we'll be doing otherwise can be very well taken away, right? And one more important thing that will happen with this case is that suppose if we are given with an array of size 1, okay, so let's discuss that case also, wherein we are given with an array of size 1. So suppose some array of this form is given and we want to rotate it 2 times, right? So what will happen, that first of all we'll calculate the mod. So this is 2 mod 1 and this is 1. So it simply means that only one rotation is being made. So minus 10 will be our final answer, of course. So for such cases, k mod divided is very important because you can skip those extra steps, right? You can skip those all rotations, which will just lead to a more complex, a more time complex algorithm. So just to remove that extra time, we are using this mod divide concept, right? So I hope this is clear. So now let's start with our first approach. So in the very first approach, what we are going to do is that if suppose we need to start with the rotating part, the very first algorithm, right? So the very first algorithm is going to be very simple one. Okay, we're going to do the same thing which is done here in the explanation part, that is we are going to rotate every element one by one, right? So let's just start with that. We have discussed that also right now, so we can start with the implementation part. So let's see that. So first of all we are given with this array, right? And what we're going to do is that we are going to have this array nums, wherein we are having 7 elements, right? And one by one we are going to rotate. So right now k is equals to 3. What we can do is that we can have 2 pointers, right? Every time, if you will see on rotation number 1, 7 is at the first place, and then 1 is shifted 1 by 1, right? Then 2 is also shifted by 1, so here we are having 2. Then 3 is also shifted by 1. It means whole array is shifted by 1 except for 7, which is coming to first place, right? So 1 2, then 3 is shifted to the next place, then 4 is shifted to the next place, 5, then 6, right? And that's it. So this is what we're going to do. So the approach would be very simple, that initiate a loop for k times, because k rotations are to be made, right? And afterwards have one pointer. So suppose if this is our array, so what we can do is this. First of all, of course 7 has to go to this place, right? And just before moving this, so we'll store this 7 into our temp variable, and we'll have this one pointer here, right? And the next pointer here, and we'll just swap these two things, right? Or instead of swapping, we'll just copy this 6 to this place. So right now this will become 6. In the very next iteration, what we will be doing is that we'll move our pointer to 5, okay? And then again 5 will be copied to this place. Then we'll move our pointer to 4, then 4 will be copied to this place. So at this point our array will look something like this, that is 1 2 3 4 4 and then 5 6, right? In the next step, while our pointer is on 3, we'll again copy this 3 to next place, and then same thing will happen with 2 and 1. So at the end, when our pointer is pointing at the 0th location, our array will be looking something like this, right? And now the 7 which we were having in the temp, right, we can just copy paste it here. So right now 7 will come here, right? And this process of moving one element every time has to be done k times, because next time now temp will store 6, right? And this again the same loop, same iteration will go for this array this time, right? 7 1 2 3. So what will happen, 5 will come to this place, 4 here, 3 2 1 7, right? And now because at the end the array will look something like this, that is 7 7 1 2 3 4 5, and now the temp which was storing our 6, we can just copy paste it here, right? So k times this has to go on, and at the end when k iterations are completed, at that time we'll have the final array in this particular format, that is the answer array, which is this one. The final outcome will be this one: 5 6 7 1 2 3 and 4, and this is our required output also, right? So this is a very simple technique. Let's start doing it. Okay, so very simple technique wherein we are rotating our array n number of times. So first of all, let's have a final value for our k, that is k is equals to k mod divided by nums dot length, right? So that we can just stop that extra rotations that are needed, right? And afterwards we'll have two for loops, one wherein we'll have this kind of k iterations for, you know, for each subsequent shifting. So int I is equals to 0, I less than k, and I plus plus. So how many total rotations are to be made, this is mentioned in here. And then this second for loop is, or the second loop is basically where we are shifting within a particular rotation, we are shifting this all the elements by one position. This is second loop is for that purpose basically. So here what we're going to do is that we have to start shifting, or we have to start copying the elements by one from the very last index, right? So second last index basically. So in j is equals to nums dot length, right, minus 2, you know, the reason is that we have to start from the second element. We have to just pick this 5 and then we have to paste it here onto 6, right? And then every time we have to do this until we are greater than 0, right? And then j minus minus for each element. Now one more thing that we have to do is that we have to pick one element each time. So int temp is equals to nums dot length, the very last element we are picking and storing inside our temp, length minus 1, right? And afterwards in this for loop, in the second for loop, what we're going to do is we'll just pick one element, that is nums j plus 1 is equals to nums j, and that's it, right? After k rotations we'll have our element sorted, and the very last thing is that we have to put in the 0th position the temp, and we have this sorted array, right? This was our algorithm, a very simple one, but of course not very time efficient. Why? Because suppose if we have to discuss this case also, wherein suppose we are having this array 1 2 3 and 4, right? What if we are given with 3 rotations, suppose, right? So after 3 rotations, our array will become something like this, that is 2, 3, 4, and then 1, right? This time n was equal to 4, but what if the number of elements are like greater than 100 or 1000 or whatever the range was, right? So this algorithm will become very inefficient, because 3 times rotation simply means that you are basically n minus 1 times. If you are asked to rotate the array, then n minus 1 into n, right? So into n for this particular reason, that you are copying and pasting or traversing your whole array each time when you're rotating it by 1, right? So for that purpose, the time complexity is n square, which is not a very good thing, right? But of course this was a brute force kind of a thing, because we are doing the same thing which we can see in the example, right? So let's run this problem. So at least we have this one solution at the moment. Okay. So this is a wrong answer, but the reason behind it is very simple, which is, so first of all, we have copied the 7 here inside this temp, right? And now we are going in here wherein हम लोगों ने last element को उठाना है, and we are pasting it to the next place, right? So the thing that is happening here is that every time you are shifting the elements, you're doing it right, but it should be like j should be equal to also, no? That is why this problem is happening. So let's see. It was running for certain cases, but not for, so time limit exceeded, this problem is coming. So of course we have seen the reason, but this was the 37th case. So the input size was very big, and that is why the n square time it was taking to solve this problem. That's why time limit exceeded, this issue has come. So we definitely have to resolve this issue. We have to come across with a nicer solution also. So let's carry on with the nicer one then. So this is one of the techniques, but of course we cannot use it because of the time complexity of n square that it is showing, right? So the next thing would be, so let's just start with the next technique, which is an efficient one, wherein we'll be storing some block, right? So very efficient technique here. What we are doing is that, suppose we are having this array 1, 2, 3, 4 and 5, and now we want that k is equals to 2. It means we want rotation of size 2, right? 4, 5 will come at the front and rest of the elements will be shifted. So a very simple technique would be, the output that we require right now is 4 and then 5 should be here, and 1, 2, 3 should be here. So a very simple technique would be that take an additional array, right, of size k. Okay, it means of size 2. So we have this array of size 2, wherein we'll copy the last 2 elements, because of course they have to be shifted. If you'll see, it is a very simple technique wherein we are just pasting these 2 elements from here to the front, and rest of the elements are shifted by k equals to 2 position. That is, 3 will be shifted by 2 position, means 3 will come here, right? And then 2 will come to next second position, and then 1 will come to plus 2 position, that is here. So something like this is happening with 1, 2, 3, wherein 4 and 5 are basically coming at the very front. So our technique is very simple, that is store 4 and 5 in a different array and then shift these elements by k equals to 2 rather than. So what we were doing at the moment was that we were shifting in steps. So in a step 1 we'll shift all the elements by 1, then in step 2 we'll shift all the elements by 1. So right now we just want to remove some of the extra steps, so for that reason in a single iteration we'll shift all the elements by 2. Before doing that, we'll store these 4 and 5 somewhere, because otherwise we'll lose them, right? We don't want that. So in the first step, what will happen? We'll copy and paste array, nums array 4 and 5 into some other array in order to store them. So it is similar to that temp that we're using. Okay. Afterwards, in the first step, so this was the first step. In the second step, we'll move all the elements by k equals to whatever the k is. So 3 will come here at the end, then 2 is shifted to next second place, then 1 to this place. Now we have these two spaces still vacant. Vacant simply means that right now they are containing 1 and 2 only, right? But we have shifted all other elements and they are at the correct position now, right? This was the order in the final array also. And now we simply can paste this 4 and 5 into our original array. So 1 will be overwritten with 4 and 5 will overwrite 2, right? So our original array is this, that is 4, 5, 1, 2 and 3, right? So same thing in code. If you will see, a very simple technique again. So we have this temp array, right? In this temp array is basically of size k, right? So new int k, and now just let us copy these all elements, right, from nums to k to temp array. So a very simple approach would be to have your first pointer set to k and nums dot length minus k position. So let's have this pointer here. So int I is equals to nums dot length minus k, right? And while I is less than nums dot length, till then we can repeat the procedure, that is temp j is equals to nums I, right? Now j is basically pointing the very start of, at the initial stage it will be pointing to the very beginning of temp array, that is j is equals to 0. So what we are doing here is we are just simply copying all the elements from nums to temp, right? So now we have this store wherein we have 4 and 5 at their accurate positions also. Now the second thing would be to shift all the elements in the original array by 2 or by k, right? So for that reason we'll have again a loop. In this loop, so this is while, right? And we have to set the pointers first of all. So the initial pointer will be at 3, right? So we can say that the first pointer, suppose it is I, so I is pointing to nums dot length minus k minus 1. So if we'll see in this picture, right, it is something like this. That 1, that 1, 2, 3, 4 and 5, right? So in this step 1, what we have done is that we have this temp array, and inside this temp array we have stored 4 and 5. Okay, so now nums arrays is still the same, but this 4 and 5 are stored in temp array. Now we want to move all the elements by 2 because k is 2 here, right? So first pointer we are setting in here at 3, and the second pointer we are setting to this place, that is 5. Okay, and one by one we are copying, right? So we have set these 2 pointers, and now at a step 1 or iteration 1, our array will look something like this, that 1, 2 and then 3 is pasted to 5th, will override this 5, so 3 is here, right? And now we'll decrement the pointers by 1. So now one pointer is pointing to 2 and the other one is pointing to 4, and again the same process will be followed. So 1, 2, 3, 2, 3, this will be our new array, right? And again, because the iteration has to be done 3 times, because we were having 3 other elements which needs to be shifted. So again the third iteration would look something like this, that we are having these 2 pointers here and here. So 1, 2, 1, 2, 3, right? These 2 elements are, this one is copied down here. right? And now simply in the next step, what we will be doing is that we'll copy the elements from temp and we'll paste it here. So we'll pick this 4 and we'll paste 4 here, and then we'll pick this 5 and we'll paste 5 here, and this will be our final array. So this was our I, right? This was our I initially, and j will be at the very last position. Okay, so right now I is pointing to 3, wherein we want j to point to nums dot length minus 1, and simply while I is greater than equals to 0, what we have to do is that we have to do something like this, that is nums j yes, is equals to nums I. So all the copy pasting things are done by k steps, right? And each time while you're doing this, just do one more thing, that is I minus minus and j minus minus. And a similar thing has to be done here also, wherein we have to increment I and we have to increment j while preparing our temp array. And the last thing would be to copy the elements of temp into nums. So very simple process again, which is while k is, so first of all let's have these 2 pointers set again. So I right now will point to 0 and j will also point to 0. So we don't need even 2 pointers. So while I is greater than k, until then what we have to do is that nums I is equals to temp I, right? We don't need 2 pointers basically. So then I plus plus, and we have set our nums array again. So now let's submit it again. So 9th case is not passing. Let's see. So maybe we have done something here. So we are assigning nums I with temp I. So what are we having in temp? Let us see. So nums is set to nums dot length minus k, which is right. Okay, let's see it. So first of all, we'll have all the elements set here. Then while it is greater than 0, so all the swapping has been done. And this is the next loop, that is while I is greater than k. So are we changing k anywhere? No. Okay, this condition is a bit wrong, so I should be less than k. Now let us submit it. Okay, so it is having a runtime of 1 milliseconds, wherein very little memory is used. Basically the minimum memory is used. Now the next case is very simple, because now we want the runtime to be even less than the one we are having at the moment. So for that purpose, what we'll be doing is we are going to use the next solution, wherein what we are going to do is, so again we are having this array, one, 2, 3, 4 and 5, and the final array is this 4, 5, 1, 2 and 3. So k is equals to 2 in this case. So basically if you'll see now, so it is something like this, that this 4 and 5, they are pasted directly here, and this 1, 2, 3, these are directly pasted here. So the technique is very simple, that if we'll reverse an array, so suppose if you're reversing this array, right, so it will become something like this, that is 5, 4, 3, 2 and 1, right? But what we want is that, so if you'll see, the order is right? So this 5 and 4 have come to this particular position of 0 and 1 where they were required. Then 3 to 1 are also at the correct position. Of course, a little bit reversed, but the order they have got after reversing the array. Right, after reversing, we have seen that we can see that 5 and 4 a bit interchanged, but are at their actual position of index 0 and 1. If we'll reverse these two elements, it will become correct. So if we'll reverse only these two elements, it will be 4 and 5, which is right. And if we'll reverse now these three elements, they will become 1, 2, 3, which is right again. So this is the procedure which we have to follow. That first of all, we'll reverse the whole array, right? So after reversing the whole array, so the last two elements will come to the first place, and 1, 2, 3 will go to the last place. That is right. And afterwards, we'll reverse the segments of this array based on what is the value of k. So if k is equals to 2, so we'll reverse the 0 to 2, that is first two elements, and then the remaining elements. If k is equals to 3, then we'll reverse the first three elements and then the remaining elements, right? So what we're doing is that first of all, reverse the whole array, and then divide your array into two parts, that is based on the value of k. So first k elements will come into the first part and the remaining into the second part, and then reverse each of the segment individually, and we'll get a final array, right? So for reversing, the technique that we can use here is quite simple. Which was 1, 2, 3, 4, 5. So first of all, we have to reverse the whole array. So we can set two pointers. This is I, this is j, and we just have to interchange, right? So after first interchange, it will become 5, 2, 3, 4, and 1. Okay. Afterwards, increment I by 1. So I is here, j is decremented to 1. So this is I, this is j. Interchange these two. This will become 5, 4, 3, 2, 1. And if I and j are at same position, we can stop. Okay. So until I is less than j, until then only we have to do the shuffling, and afterwards we can stop, because here we are getting our original array, right? So this is the way we are going to reverse. So now only index we have to keep in mind. So let's start. So first of all, let's have a function called reverse. So public void reverse. So it is going to get a number array, and then the start index and the end index. This is the parameters that this reverse algorithm requires. And while start is less than end, do the following. What do we have to do? We have to simply interchange, right? So int, basically swapping has to be done. So swapping logic is very simple. That is, while nums temp will store nums start, nums start will store nums end, and nums end will again have temp. So this is the logic for swapping, and that's it. So we just have to increment the start pointer now, and we have to decrement the end pointer. So this particular thing will be carried out only until this condition is satisfied. Once this is over, our array will be reversed. So we have to do 3 reverse, right? So reverse number 1 would be of the whole array, wherein we'll pass the indexes, that is nums 0 to nums dot length minus 1. This is our very beginning. This is our full array, and afterwards the next reverse would be of nums from 0 to k minus 1, right? The first 3 elements has to be reversed. So this is done, and then the last would be from k to nums dot length minus 1. This is the remaining elements that we are having, and that's it. So in place rotation again. So yeah, we're done with it. So method reverse, some problem is coming, which is, right, we haven't passed this nums array here. Okay, so some problem with the, I guess, the namings. So nums is there. Okay, so we have passed this solution again and again. If you can see, the memory utilization is very less, and of course we have achieved the 0 milliseconds time frame also. So this was our question on rotate arrays, right? So we can have this question again here. This was problem number 189, rotate array. So I hope this is clear. See you in the next video.